for number 5, tell me what the ramp was like. I'm just gonna here where it's bigger.
Slant it up from the 0 position.
Which toward the right, slide it up,
From the 0 position.
and that's where 0 is. The ramp looks like this. Motion detector at bottom or top?
Bottom part of the bottom.
Bottom motion detector.
It's the one where you push it up and then let it come back.
Okay, so the car's gonna go up the hill and then turn around and come back down the hill. So it you give it a push here, so it's going fast at the beginning. So this is how I like to approach a problem like this, just kind of like in my head, like explain out the whole scenario, because then it lets you trickle down into the graphs and motion maps. So I'm gonna say right here, so it's fast at first, and the 0 meter mark is the motion detector, so plus is uphill. So we're going fast in the positive direction, and then we're gonna reverse. So we're gonna slow right down and then turn around and go the other way. So we're slow going back downhill to fast at the end. So motion map, positive direction out there, 0 here. What should my dot patterns look like?
Big spaces, the little spaces, and the little spaces, and big spaces. I like that.
Okay, so there's the way up. Big to little spaces, positive velocity because we're heading in the positive direction. Okay, I'm going to change colors. So the way back down, is there any symmetry, do you think? It's going to slow down because gravity makes it do that. And gravity's still what's making it speed back up. So it's a pretty good guess to say, yeah, there might be some symmetry there. Hello?
How are we doing?
We can't be any better. What is the velocity on the downhill, positive or negative? Okay, so they're negative and they're getting bigger in the negative direction. So position time graph. Oh, I didn't put acceleration down there, the most commonly overlooked thing. On the way uphill, it's slowing down. So is the arrow point to the left or to the right for acceleration? We're slowing, so we got to remember that rule. So the acceleration got to point that way, which is the negative direction. So negative A. How about coming back downhill? It's speeding up now. So the acceleration would be that way because the rule says if I speed up, my acceleration points the same way as my velocity. Is it negative now or did it flip to positive? Still negative. So it's still negative. Okay. Position time graph. Our rules, our checklist over there. We start fast or slow. Sorry, start far away or close to the origin. Start close, so we should start off down here. Were we going fast or slow to begin with? So steep has to go like kind of like number 2 group, and it's slowing down, so it gets flatter. So at the top of the ramp, we're going to be kind of at the top of this hill. As we speed up going the other way, then it looks like one of the other ones. I forget which one. So our position time graph is going to look like a full parabola. How about our velocity time graph? We're going fast in the positive direction, you said? So where does that start me here? Somewhere's up here. And I'm slowing down, and when I hit to the top of the ramp, I'm reversing direction. So my speed is changing from positive to back to negative. So I got to cross through the 0, right? Is there symmetry then you figure on this where it just continues down? Sure. Okay, and then last but not least, the acceleration graph. Acceleration, according to our motion map, was negative on the way up and on the way down. Negative. So if 0 is here, acceleration should be somewhere down here, -2, -5, I don't care what you want to call it. Remember also that the slope of this graph should confirm that as well. It's a negative slope the whole time. It's not a positive slope and then a negative slope. Numbers might be, but the graph itself is not. You guys did good today.